So here we can see that they're definitely asking us to find the slope of the line. And what's helpful to know is what format the equation is that's given to us. And if you recall from page 33 of our math reference document, you can see that right now we have standard form. Our goal really is to get into slope-intercept form so that we can readily find the slope, which is the constant directly in front of x. So let's look at this by hand, and then I'll show you kind of a neat trick with Desmos that applies in most situations. So first, let's go ahead and get y by itself. To do so, let's first get rid of this 8x by subtracting it to both sides. And even though I could put 1 minus 8x on the right side, because I know I want it in slope-intercept form, I want it in mx plus b. And then I still have on the left side this negative 6y. Really important that you keep that negative in front. And then to get y by itself, we're going to divide everything by negative 6. I like to show it for all three parts here. However, all that really matters is the slope, so it doesn't even matter that this is negative 1/6. But what really matters is the fact that two negatives make a positive, you get 8/6. And what's neat is you could actually type in 8/6. That should be acceptable. To my understanding, it doesn't have to be reduced. Obviously, you can reduce it in your calculator on Desmos, or you probably just know that you can divide top and bottom by 2, and you get 4/3. Or let's say we actually are in Desmos. Let's say we did the 8/6. You get this decimal, you could go like this and it reduces it for you. But if you did want to put the decimal equivalent, you could do so 1.33 and just fit as many as you can, which in total is 5 characters. So any of those options totally work. Personally, I would just type in 4/3 as my answer. But another thing that you could do is, let's say you were typing this in here, 8x minus 6y equals 1, and you have this line. Obviously, you could try to do rise over run, but let's say you can identify 2 points. This one's very clear. You could tell it's not a rounded decimal. However, when I look instead at the y-intercept, you can tell it's rounded. And if I try to find any other point, it's just these are crazy decimals all around, which is pretty rare. But in a normal situation, you could just go to table, and let's say you put those in. Let's say 0, negative 0.16667, and then over here 0.1250. When you go to this, which is add regression, you could see the slope as 1.3333, and that actually would have worked as well.